Now that you have some idea of how to take a frequency distribution table and turn it into a histogram, I want to take a moment to talk about how histograms can show you the shape of your data, or the shape of a distribution. Okay. And when I talk about the shape of the distribution, what I mean is literally the shape of, for example, the graph. When you create a histogram, you've got a little graph here, and this is going to have bars. And we can imagine, I know those bars aren't supposed to have gaps in them, but these ones have a little bit. I'm trying to draw this quickly. But what we can do is we can look at the shape that these bars make, and you can imagine drawing a line that kind of connects the tops of these bars, and that line shows you essentially, in an abstract way, the shape of the distribution itself. And so we can distinguish between a few different types of shapes. There's basically two basic types at this point that are important to consider. There are normal distributions, and normal distributions have some important characteristics. They tend to be symmetrical. Okay, so the left side looks like the right side. You could kind of fold the graph over on itself right down the middle, and they would seem very similar. Sometimes these are called bell curves because of that, because if you imagine the shape of a bell, you'll get that shape in the curve itself. Aside from being symmetrical, normal distributions tend to have their peak, or the most frequent number of observations, occurs at the middle of the distribution. This is the most frequent value. And then they'll have the fewest values at the high and low ends. Okay, and these are called the tails. Okay, so you've got a peak in the middle, and then you've got tails on the left and the right. And to give you an example of what we mean by this, I can show you create a small frequency distribution here for variable A, and we'll say that A has a frequency that looks like this. The values are 0, 1, 2, 3, and 4. The frequencies then are 1, 2, 3, 2, and 1. If we add up these frequencies, we'll see 2 and 1 is 3, plus 3 is 6, plus 2 and 1, that's another 3. So we have 9 observations, and we can create a frequency distribution that looks something like this. And so we've got our x and y axis here, and this is going to be our frequency. We've got 0, 1, 2, and 3, and then our values for A, which are 0, 1, 2, 3, and 4 here on the x-axis. Okay, so now we can draw our frequency distribution here. There was 1, 0. There were 2 1s. There were 3 2s. There were 2 3s. And there's 1 4. And now this histogram, right, we just created a histogram of the frequency distribution for A, and so we can now look at these frequencies in this graphical form, and we can connect sort of if you imagine connecting the dots at the top of each bar here, we can create a line that represents this distribution and goes through each of these. And here you can see a classic example of a normal distribution or a bell curve, in which we've got the peak right here, right? So we've got the peak with the greatest frequency value at 2 with a frequency of 3, and then we've got the tails. There's a tail on the right hand side, and there's a tail here on the left hand side where we've got the smallest number of observations, where there was just one observation with a value of 0 and one observation with a value of 4. And so this is the basic idea of a normal distribution and using a histogram to talk about the shape of your data. So aside from a normal distribution though, we can also have non-normal distributions. And this is the other major kind of shape to think about. And non-normal distributions have some important characteristics. In general, they will not be symmetrical. Okay, so you won't be able to fold them in half over and fold one side over on top of the other one, have it look similar. They will have the peak not in the middle of the distribution, but either on the left or right side. So peak on the left or right, depending on the kind of non-normality we're dealing with. And in fact, we can classify these. If the peak is on the left hand side, okay, if this is on the left hand side, then this is going to be called a positively skewed data, or it'll be a distribution that has positive skew. And if the peak is on the right hand side, this will be a negative skew. Okay, and so generally what you'll have is you'll have a peak on one side, left or right, and then you'll have a long tail on the other side of the data. And so we can demonstrate this here with one distribution. Let's say for variable b, we'll create a frequency distribution, and we'll say that the frequency distribution for b looks something like this. We'll have the same values, 0, 1, 2, 3, and 4, and the frequencies go like this: 3, 2, 2, 1, 1. And so we've got 3 plus 2, and 2 is 4, that's 7, plus 2 is 9. We still have 9 observations. And what we'll do here is we'll create our frequency distribution graph right here. And again, we've got values that go from 0, or well, they're from 1 to 3, but we could graph the frequencies from 0, 1, 2, and 3. And then we've got values for variable b that go from 0, 1, 2, 3, and 4. And we can fill in our bars to look something like this. We've got 3 observations with a value of 0. We've got 2 observations with a value of 1. 2 more observations with a value of 2. 1 observation with a value of 3, and 1 observation with a value of 4. Now, once again, we can connect the dots. If you think about drawing dots across the top of this distribution, we can draw somewhat of a smooth line here that maybe we don't go through all the dots, but we can certainly show you that there's a peak on the left hand side of this distribution and that there's a long tail, right? So we've got this peak at the top here, and then we've got a long tail out here on the right hand side. So because this peak is on the left hand side of the distribution, this is an example of a distribution with positive skew. Okay, it is not a normal distribution, it is a skewed distribution, and because it has this shape with the long tail on the right and the peak on the left, we call it a positively skewed distribution. Okay, so what does this look like then? Let me erase some of this, and we'll show you an example of a negatively skewed distribution. Let me redraw our graph here because we'll have data that's very similar. 1, 2, 3. So then here we'll create another frequency distribution. We call this variable C, and we'll give variable C the following distribution. We'll say its values are the same, 0, 1, 2, 3, and 4, and the frequency distribution follows this. There's 1 0, there's 1 1, 2 2s, 2 3s, and 3 4s. Now you can probably already see where I'm going with this. We still have the same sample size of 9, and we'll fill in our table now with 1 observation at 0, 1 observation at 1, 2 observations at 2, 2 observations at 3, and then we'll have 3 observations at 4. And once again, we can think about connecting the dots on these bars, and what you'll see is if we loosely connect these dots, but again we're just talking about the abstract shape of the distribution here, you'll see that we have a tail on the right hand side where there are fewer observations, right? And that there's a peak. I'm sorry, the tail's on the left hand side and there's a peak on the right hand side. Okay, so this peak is on the right, the tail is on the left, and because we've got that peak on the right hand side, this is an example of a distribution that has negative skew. So again, this is not a normal distribution. This is a skewed distribution where the peak doesn't lie in the middle, it's not symmetrical, and because the peak lies on the right instead of the left, we call this a negatively skewed distribution. And so this is just a couple of examples of using histograms to determine the shape of a distribution, both for normal distributions and non-normal distributions.